Problem number 8. Okay, so let's write down what we do know from problem number 8. Okay, a gas at 110 kilopascal. Okay, so that means we have a pressure, we'll call it P1, equals 110 kilopascal, okay, and 30 degrees Celsius. Okay, so we have our temperature, T1 equals 30 degrees. Fills a flexible container with an initial volume of 2 liters. Okay, so initial volume equals 2.0 liters. All right, just making sure it fits. Okay. If the temperature is raised to 80 degrees Celsius, so this is our second temperature, 80 degrees, and the pressure increases, so we have our pressure 2 equals 440 kilopascal. What is the new volume? So right here, we don't know. Okay, so we have a couple different things that we have to do. First off, because we are dealing with the combined gas law, all right, so this is the combined gas law, right, because we have 2 P's, 2 T's, 2 V's, so we know it's combined. The one thing we have to do right away is we have to change our temperatures from, degrees Celsius, sorry. We have to change this to Kelvin. And so if you'll remember, Kelvin is degrees Celsius plus 273. So all we're going to do is we're going to add, for this first one, we're going to make a quick change. We're going to add 30 degrees to 270, so it would actually be 303 Kelvin, and then we're going to add 80 to this one, and that's going to be 353 Kelvin. So that's the first thing we actually have to change. All right, now let's go ahead and do our formula. Our formula now for the combined gas law is P1V1 divided by T1. Now, a lot of times people will write this out. They'll write it like this, P1 times V1, okay? Well, all I did is get rid of the times symbol in the middle. And so that's why I write it that way, P1, V1. Okay, equals P2, V2, all divided by T2. Okay, and what we really want is we want this V2 all by itself. So what we have to do is we want to isolate V2 by itself. So we're going to have to take this T2, multiply both sides by T2. So if we do this, that cancels, but then we have the T2 over here, okay? And we also want to get rid of P2, so we'll divide by P2, which means those two cancel, and that means we have P2 on this side. So in reality, our new formula after manipulation is going to be V2 equals P1 V1 T2 all divided by T1 P2. Okay, so what we're going to do is we're going to take all this here, we're going to come down here and plug in these numbers. All right, P1, 110 kilopascals times 2.0 liters times, and our temperature this time is 353 Kelvin, all divided by 440 kilopascals over 303 Kelvin. Okay, now real quickly, I'm just going to cancel out the units. So you see that, and all we're left with is our liters. Okay? All right, now we could just crunch it straight into our calculator. If we crunch it straight into our calculator, we end up getting on top 77,660, all divided by 133,320. And when we do this, finally crunch that into the calculator, we get 0.58 liters. And that is our second volume that we are looking for. But remember, there's a couple different steps here. We do have to change and convert from Celsius to Kelvin. We have to manipulate the problem in order to figure out, isolate what value we want, and then crunch in the numbers and stuff. Okay.